Hi everyone, this is MK, another problem from LeetCode Daily Challenges. Today's problem is interesting because it has several different solutions. You don't have to just think about one specific solution. Let's read it and I'm going to discuss the solutions. I'm going to discuss two solutions and write the code for two solutions. And then I'm going to give you some hints to think about a third way of solving this problem. So stay with me. Length of longest subarray with at most k frequency. Okay, if you have solved the past few days daily challenges, you know the theme of the week is subarray, contiguous subarray, something like that. So whenever you are faced with a problem that is working and talking about subarray, something that you should come to your mind is a sliding window. But let's first read the problem statement. I was assuming that you have read it, but that's not a correct assumption. Some of you don't read and come to the video directly. So we are given an integer array nums and an integer k, all right? The frequency of an element x is the number of times it occurs in an array. And an array is called good if the frequency of each element in its array is less than or equal to k. Okay? All right. So now we should return the length of the longest good subarray. And then it goes on to explain what a subarray is if this is the first time you are encountering this phrase, this terminology. A subarray is a contiguous, non-empty sequence of elements within an array. All right, contiguous sequence. All right, so how do we think about this problem? First, the constraints are that the length is 10 to the 5, so we cannot do an O of n squared. We cannot check all of the possible subarrays. All of the possible subarrays, it's going to be O of n squared. You can think why. The total number of subarrays is n times n plus 1 over 2 plus n. Why? Oh, no. Sorry. That is it. That's it. This is the total number of subarrays of an array. So, and when n is 10 to the 5, this is a big number. We don't want to, we cannot do and check all of the subarrays. So again, as I said in the beginning, you should probably think about a sliding window. What is a sliding window? A sliding window, one variation of a sliding window is a window that is expanding from right and then shrink from left. Okay, I get it. Thank you. But when do you expand? So you keep expanding the window as long as the condition is met, as long as the subarray is good. And you stop expanding once one element is violating the condition. You stop there. So you expand, and then you stop. You stop the moment that the condition is not met anymore. What does that mean? That means there is one element that its frequency is greater than k. So let's like frequency of some, let's say ch character, some frequency of some ch is now greater than k. And greater than k, what does that mean? That means it's exactly k plus 1 because it just violated the condition. So that means before this step, the frequency was k, and now the frequency is k plus 1. So now you stop. You stop expanding, and now you keep shrinking. You keep shrinking until some point that the condition is met and your subarray is good again. Right? Let's go and see one example. So whenever I'm teaching problem solving and algorithms, I try to separate the idea phase from the coding phase. So first you should understand what is actually happening, and then you should be able to convert that idea into code. And these are like three different skills. The first one is problem solving. Like, are you able to solve the problem? The second one is coding. So that is like, are you fluent in your programming language of choice? Do you know how to implement a map? Do you know how to implement a set? Do you know how to implement a recursive function? So this is the second one. The third one is connecting the two, like converting an idea into code. Do you get it? So when I conduct interviews, when I conduct mock interviews, I see people who are very good at the ideation phase. They can solve the problem, but they cannot write the code. And I'm sure they are good programmers. Like, they know how to write a recursive function. They know how to write a set or a map, but they cannot convert that idea to a code. So these are three different skills. And most of the people are good in two of them, and sometimes they miss the third one. So here, let's see what happens with the sliding window. So we have a sliding window. At first, this is the sliding window. So then we keep expanding. So the condition is met. K is equal to 1. So you see frequency of all the ones in this window are less than or equal to 1. So we keep expanding. Okay. All right. Now everything is good. We keep expanding. Oh, sorry. Now this is the first time 1, 2, 3, 2. This is the first time that we are violating the condition. So now we should shrink. We shrink, and this becomes our window. But still, this is still violating the condition. We shrink one more, and now this is our window. All right. So this is the current window. We keep expanding. So we expand one more. Everything is good. We keep expanding. Everything is good. 3, 2, 1, 4. All right. We keep expanding. All right. This is bad. So 3, 2, 1, 4, 3. Now we should shrink because we have violated the condition. So we shrink. And now we have 2, 1, 4, 3. This is how the sliding window works. So we expand. We expand. Oh, we shrink because it's bad. So at any given point, the window that we have is a good window. So you see here, it's 1, it's good. Here, 1, 2, it's good. Here, 1, 2, 3, it's good. 3, 2, it's good. 3, 2, 1, good. 3, 2, 1, 4, good. 2, 1, 4, 3, good. So you see that? We expand, we shrink until we have a good window. So let's go now and write the code. Okay, in order to write the code, we need a start and an end. A sliding window has 2 points, two endpoints. So let's start to be 0, and also we have let end to be 0. All right, so we need let end to be nums.length. What else do we need? We need a variable for the answer. So let answer to be 0. And we needed the frequency table actually. Let frequency, which is a map from number to number. So this is how we define a map in TypeScript. New map. All right. Now we start. We start while end is less than n. That means while we can expand the window. While we can expand the window, we increase the frequency of that letter. All right. So we say frequency.set what? What's the key? The key is nums of end. So what do we set here? We should ask the frequency so far. So we say, hey, fric.get nums of end, or 0 if you don't have it. If you don't have it, give me 0. Plus 1. This is how we increase the frequency in here. So now if we just violated the the condition. So if fric.get nums and greater than k, so that means we just violated the condition of a good subarray. If this just happened while we are not back to normal, while we are not having a good subarray, so that means while the frequency of this current character is greater than k, current letter, all right, we know the one who violated the condition is this one. So that's why the condition of the while loop is based on the frequency of this letter, all right? So while this is greater than k, we keep shrinking. We keep shrinking. How do we shrink? We say, hey, fric dot set. So what is the key? The key is the nums start. Nums start. What is the value? The value is fric dot get nums start -1. We know this time that this key exists in the frequency table. That's why we got rid of the or. Okay. And yeah, that's it. And then start plus plus. Okay. So when we get out of this, when we get to this line of code, that means our subarray is a good subarray. Okay, so we update answer. So answer becomes maximum of answer and end minus start +1. This is the start to end. This is inclusive. And then we just increase end. We move end one step forward, and then we just return answer. Let's test. Okay, 3 green flags and submit. Okay, let's talk about the second solution. The intuition for the second solution is like this. We are still working on with the sliding window, but this time we only expand. We don't shrink. We either expand or slide. Let's see how. So let's say the intuition is this. Let's say you find a subarray of length, let's say 4. And this is good. This is a good subarray. Okay. So either this is the answer. That means you will never get any other subarray with length greater than 4. Or at some point you will be able to expand this. For example, here you will have a sliding window of, you will have a subarray of length 5. And again, this 5, either this 5 is the answer, or at some point in the future, which could be here, you get a subarray of length 6. And so on. Again, either this is the answer, or at some point you will get a 7. And so on. So, all right. That sounds about right. Correct? So we don't care if we are seeing all of the good subarrays of length 4. What we care is to find the length of the longest subarray that is good. So whenever we are not meeting the condition, instead of expanding, we just slide. So we slide because we are not meeting the condition. We slide. And then here we don't slide. Here we expand actually. And again, here we slide. We slide, and then here we expand, and so on. All right, so let me give you an example. So our sliding window as first is this. So this is a good subarray, all right? I'm just gonna explain the concept as I explained for the first solution. I'm not getting into the details of how we are working with the indexes. I'm just going to show you what happens to the sliding window, then we will take care of the code. So this is a good sliding window. So we keep expanding. So this is good. So we keep expanding. This is good. We expand. Now we want, at the next step, we want to expand, but it's not a good slide. It's not a good subarray. So we just slide. So this is red represents a bad subarray, but the length is 3. All right. So we slide. So we slide it one more, but now this is a good subarray because it's 3, 2, 1. Okay. On the next step, we expand because it's 3, 2, 1, 4. All right. And again, on the next step, it's good because 3 is out and another 3 is in. So I hope you get the idea that when the condition is not met, we just slide. We slide, 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 slide. At some point, we get to expand again or not, if that is the longest one that we can ever see again. So let's go and write the code. In order to implement the code, we need to keep track of the number of distinct letters that are violating the rule. That means how many letters have frequency greater than k. So I'm gonna have a variable for that. So let violating letters count. I'm gonna initialize that to 0. So we have some start, and which is 0, and then we need to do a for loop and expand. So let end equals 0, and is less than nums.length and plus plus. So we need the frequency table. We still need that. So let fric equals map of number and number equal to new map. And here we need to increase the frequency of the letter at index end. So fric.set. What is the key? It's nums end. What is the value? The value is fric.get nums end or 0 if this is the first time that we are setting that. All right. So if it doesn't exist, we're gonna have 0 here, and 0 plus 1 is gonna be set as the key. And now that we have set it, we should check if this violated, if this setting, this increasing of the frequency, if this violated the rule. So if fric.get nums end is equal to k plus 1. So that means it just violated. It just violated the condition. So I'm going to increase this. That's it. All right. And now we should check if we are still violating at this point. So if this is greater than 0, that means at this point, after adding this letter sorry, not letter, number. They are numbers. They are not letters. Sorry. So if after increasing the frequency of this number, then the violating letters count is greater than 0, that means we should slide. We should slide. And how do we slide? We just decrease the frequency of this number start. Okay. So frequency.set. What is the key? The key is nums start. What is the value? The value is fric.get nums start -1. So this is how we decrease that. After decreasing, if this letter was one of the letters that was violating, we decrease the count. So we just ask, hey, yes, let me check that. Fric.get nums start. If this is k, that means it was k plus 1 and now it became k. Okay, so in that case, we are going to decrease this. All right. And here we need to increase start. So that is it. After sliding, actually increase start. And that's it. Here at the end, we return nums.length minus start. So what does this mean? This means that the window that was slided to the end is the length of the longest subarray, longest good subarray. That doesn't mean that the last subarray of this length is good. That means at some point in the past, we could find a subarray of this length that was good. Okay, and let's run. Okay, that's it. And now we submit. Okay, here's the second solution. Let's go and talk about the third solution. Do you remember the second solution? That the answer is only increasing. So 4, 5, 6, 7, and so on. What does this remind you of? Like, if you keep asking this question, let me give you the question. So if you keep asking this question, is there a good subarray of length 1? Is there a good subarray of length 2? And so on. If you keep asking this question, the answer is going to be yes up until some point. So it's going to be yes, yes, yes. Let's say this is an imaginary example. Yes, 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 yes. And now 8, the answer to 8 is no. What does that mean? That means definitely the answer to 9 is no. The answer to 10 is no. And so on. So what does this format remind you of? This is a binary search. So what you can do is you can binary search for the first no or for the last yes. You can think about the details of the implementation of this problem. Thank you for watching. If you like my explanations, please like, subscribe, and introduce me to your friends. I don't have any other marketing channels or such a thing. Thank you.